हेलो फ्रेंड्स, वेलकम बैक टू मेरा व्लॉग। और आप लोगों का स्वागत है BIT सिंद्री के कैंपस में फिर से। तो अभी हम जा रहे हैं डिपार्टमेंट। आज हम लोग के कॉन्फ्रेंस रूम में होने वाला है कुछ टॉपिक को लेकर के डिस्कशन, जो है बायो रेमिडिएशन, जो सिविल इंजीनियरिंग में यूज़ करना या फिर कैसे उसको कंडक्ट करना, ये सारा कुछ हम लोग को आज बताया जाएगा। तो कहाँ कहाँ से सर लोग आएंगे वो तो मैं वहाँ पे जाने के बाद बताऊँगी। तो मेरे साथ चल रही है तुलिका। तो अभी हम लोग चलते हैं साथ में और बस पहुंचने वाले हैं। और बहुत दिन के बाद ये सब प्रोग्राम अटेंड कर रहे हैं। तो कैसा लग रहा है तुलिका? तुमको अच्छा लग रहा है ना? अच्छा लग रहा है। अभी सारे कोई तो नहीं आ रहे हैं, बट जिसको इंटरेस्टेड थे, जो लोग ग्रुप में मैसेज आ जाता है, जिसको जाना है जाओ, जिसको जाना है नहीं जाना है नहीं जाओ। तो हम लोग जा रहे हैं और देखते हैं कैसा रहता है आज का प्रोग्राम। तो बने रहिए हमारे साथ में। और इतना सारा गर्मी है, अब गर्मी में सुबह सुबह जा रहे हैं तो इसलिए कुछ उतना नहीं लग रहा है ना। तो चलते हैं, बाय बाय। तो अभी हम लोग आ गए हैं यहाँ पे सेल बिल्डिंग, हमेशा की तरह। अब थोड़ा गर्मी का मौसम आ गया, इसलिए थोड़ा सा पतझड़ जैसा माहौल दिख रहा होगा। तो अभी हम लोग चलते हैं कॉन्फ्रेंस रूम में। यहाँ पे देखिए बैनर, यही प्रोग्राम होने वाला है। इधर तनु वेट करिए। तनु चलना नहीं है भाई, चलो। अच्छा, रजनी आ रही है। तो हम लोग सारे को मिलके जा रहे हैं। अभी दो लोग आगे, दो लोग पीछे। तो चलते हैं, फट से स्टार्ट हो गया है। यहाँ पे प्रोग्राम हो रहा है इस पे। अब फट से चलते हैं। पता नहीं कितने सर लोग होंगे और हम लोग को पता नहीं डांट मिलेगा बाद में कि तुम लोग हमेशा लेट रहती है। सी एमटेक वाला बच्चा लोग। वहाँ पे दीप प्रज्वलन हो रहा है अभी।
फैलाने के लिए, विद्या फैलाने के लिए 49 में जन्मा PIT, ज्ञान फैलाने के लिए।
Organizing committee, students who are involved, thank you very much and best wishes.
Present here, Honorable Director Sir in absentia, HOD Sir, respected HOD, Professor UK Singh Sir, respected Professor Anil Kumar Sharma Sir, the coordinator of this program, Professor Malviya, and respected faculty members of the dais, all volunteers and all dear students. This is a very upcoming and new topic in the research area this day. And as Sir has highlighted many of the applications, and Professor Malviya has also highlighted some of the applications, I would a little bit add to that. It is a very new and coming this way of research which is used in environment, soil and construction technologies, even in health, human health remediation as well. So many of these might have learned about kanji. Kanji is nothing but the probiotic development which is good for the human health and increase immune system. So these are many applications, and along this bioremediation techniques are used for many contaminated rivers, and some of their live examples are the river rejuvenation projects. Those are taken up by some Art of Living organization and Bangalore government. Those are very fantastic examples in this line. And even some publications are there, very good publications are there in this area about concrete technology. Self-healing concrete is one of that example, and in removal of soil contamination. So these are very few very common examples, and this is coming up as a very upcoming technology. Even if advanced technology like quantum dot technology for the environment remediation and all are very important and coming as new methods of remediation. So I welcome our distinguished professors, professor from IIT ISM, Dr. Pathania and Dr. Sharma from NIT, and I hope their wisdom, their knowledge will enrich us and will give us new understanding of horizon.
Now, I would like to request our chief guest of this session, Dr. Tinesh Pathania sir, to kindly brief us the topic.
Sir, please.
Sir, please. Give him a huge round of applause.
Good morning, everyone.
Good morning, sir.
I would like to thank the Department of Civil Engineering, Bit Sindri, for inviting me on this seminar on bioremediation. So, thank you all the faculty for coming over here and all the students coming in numbers. So today I will be talking about the bioremediation. So my expertise is on the groundwater hydrology. So I will be telling you about that how we use bioremediation to clean the contaminated groundwater. So as your faculties have already mentioned that we use microbes and their capacity to degrade the contaminant. So that you will see in my presentation that basically I work in mathematical modeling. So I will show you the applications that how mathematically we can see the results and how the microbe behaves and how the contaminant is being degraded. So this is interesting field and I hope you all will enjoy. Thank you.
Thank you, sir, for providing us more knowledge about the topic.
We are honored and fortunate to welcome Dr. Anil Kumar Sharma sir from NIT Patna to this special occasion. Sir holds a PhD in Geotechnical Engineering from IISc Bangalore and a BTech in Civil Engineering from the School of Engineering, Tikkakara, Cochin. His research focuses utilizing fly ash and GGBS mixtures for improved geotechnical and geoenvironmental applications. He was awarded a SERB-sponsored project for exploring the application of microbial-induced catalyte precipitation in the stabilization of coal ash. His work inspires me. We look forward to gaining more knowledge from our esteemed guest, Dr. Anil Kumar Sharma sir. Sir, please.
Very good morning to everyone. Respected head of the department, Professor Kujur, respected professors of the Department of Civil Engineering, IIT Sindri, Dr. Tinesh Pathania sir, and all my dear students. So today I will be talking about microbial induced calcite precipitation. As we know that it is very important to actually stabilize the soil. So I will talk basically on mostly related to my project, that how we can use microbes to stabilize the geomaterials like coal ash or even sands, and also we will also highlight some of the possible results that can actually lead to the remediation of particularly related to the heavy metals. So bioremediation is a very interesting topic. I am actually thankful to the department that this topic has been brought forward, because typically we organize seminars on different fields, tunneling, then we have multi-story buildings, bridges, but we totally neglect this topic, which is sometimes very important, because we know that contamination is due to the development of industries and so many other facts. Actually our environmental is degrading, and there should be some options, or there should be some innovations that how we can actually reduce this degradation of the environment. So I will discuss more about my topic. So I hope you will enjoy, and thank you once again for giving me the opportunity to actually speak at this institute. Thank you.
Sir, for your insightful view on this topic. We are eager to learn from you.
Moving onwards, we begin our technical session with today's guest, Dr. Tinesh Pathania sir, IIT ISM. I want to add more to his achievements. He is a recipient of the prestigious Commonwealth Split-Side PhD scholarship. He has also been awarded scholarships from the Ministry of Education for his higher studies. He further enriched his research experience as a visiting scholar at the University of Manchester, UK. With his deep expertise in hydrology and water resource management, we are truly privileged to have him with us today. The podium is all yours, sir, and so is the audience. Sir, please. I kindly request all professors to be the part of the audience.
Good morning everyone, and I welcome you again. So I will be starting this presentation now. So today I will be presenting on the topic which is multi-objective optimization of in situ bioremediation of groundwater contamination. So you will see that a model which I have developed. So the applications today I will show you of that model in the in situ bioremediation of groundwater contamination. So this is something already talked about my education background. So I have a PhD from IIT Bombay, and during PhD I was a Commonwealth scholar at the University of Manchester for a year. Then I did my MTech from IIT Guwahati with specialization in water resource engineering and management, and I have a BTech from civil engineering and from NIT Hamirpur. So this is the introduction about the topic. So all of you know that groundwater contamination is one of the most serious environmental problem. It can occur through a lot of anthropogenic sources. So in my study, I have taken a topic where the source of contamination is the underground storage tank. So you have seen in the petrol stations that the underground storage tanks, they are being used to store the petrol products, diesels and petrol. So with the time, those containers may get corroded, they may get erosion, rust. So there could be a leakage out of those containers. So once they start leaking, because we cannot see, because they are in the underground. So through that leakage, there is a possibility that those contaminants can enter into the groundwater. So that is the source of contamination. So why it is important to understand this contamination is because in those petroleum products, there are toxic contaminants such as BTEX, which is benzene, toluene, ethyl benzene and xylene. So when you drink this water, there is a possibility of health risk. So that's why it is important to remove those contaminants from the groundwater. So in situ bioremediation is the best technology. So here you can see the example that these underground storage tanks, they are used to store the petroleum products. And on the right hand side, you can see a figure where this is a leaking tank. So they are taking it out. So once these tanks leak, so they release some toxic compounds. So those toxic compounds such as benzene, so it could cause leukemia. So that's why it is important to understand the contamination and think of the technology which could remove these contaminants out of the groundwater. So you can see here that this is the in situ bioremediation system where we treat contaminated groundwater by using the injection and extraction wells. Through the injection wells, we send either microbes or we send some oxygen nitrate. So we send them through a system. So we have injection wells at the upstream, and at the downstream we have the extraction wells. So in my study, with the results which I will be presenting to you is through the oxygen, means I am only considering the aerobic degradation. So in situ bioremediation system, as I mentioned, that we see injection and extraction wells. So this is a layout. So I will talk further that what is the importance of this injection and extraction wells in my upcoming slides. So because I does work on groundwater modeling, so sorry for the spelling, it is groundwater modeling. So I have developed models through these meshless methods. So you can see in this figure that there are two figures. One is the finite element method, another is the meshless method. So in the finite element method, we have a mesh, means they are combined, they have a structure. But in case of the meshless methods, you can see that there is a nodes which are in a meshless. Am I audible at the end or?
Yes, sir.
So in the meshless method, you can see that there is no such mesh. So we are representing this domain with the help of the nodes. So that is the difference. So I have used these models in my study. So I will be showing you the results later. For example, this is a aquifer. So this is any aquifer. So I want you to represent this aquifer with the help of the meshless method. So we use number of nodes. These are the field locations. So when I do modeling, so I have to insert all these information to get the results. So this is the way of representing any real field aquifer system with the help of meshless method. Now coming into the Bio-EFGM model. So I have developed this model called Bio-EFGM in my PhD. So this is the governing equation for the transport of the contaminant. So this is the contaminant. You can assume it as one of the contaminant through the petroleum products, maybe benzene, toluene, but I have taken them together called BTEX compound. So what we are doing is, this is the equation for the contaminant, this is the equation for the oxygen. So we know that oxygen tries to decontaminate this petroleum product. So with the help of these equations, what we do is we solve two system of equations, we merge them and try to see that how much concentration has been consumed for the contaminant as well as for the oxygen. So this is just the final equations of the model which I have developed. So you can refer to the paper. So in these two equations, we are using this model to see that how much concentration is being reduced with the time. So this is just a brief summary of the model which I developed called Bio-EFGM model. So just to show you the application of this model, you can assume that any aquifer system, so I am just presenting you simpler problems. So this is one two-dimensional problem where I am assuming that the groundwater is flowing from the left hand side to the right hand side. So you know that if any contaminant is being injected at this point, so it will travel with the water and there is a chance that this area could be contaminated. So this is the, you can see here that this is the situation I am telling to you, that here somehow the spillage has occurred. But if I have to show you that after 2 or 3 years of transport, how the situation will look like, so we have to use mathematical models. So for example, you can see that these are the results of my model. So when this was the source of contamination, this is the source of contamination. After 1 year of traveling of the contaminant with the groundwater, you can see that this much of area has been contaminated. After 2 years, this has been contaminated, and after 3 years, this has been contaminated. So this is something you are seeing the results come out of my model. So only the source of contamination was here only, but you can see that the groundwater has spreaded this contamination. On the right hand side, these are the concentrations for oxygen. So you can see that wherever this contamination is occupying this space, the oxygen has been completely taken up, right? So you see oxygen only in the yellow portion, and in the remaining portion it has been taken up by the contaminant. So it means if I want to further eliminate this contamination, I need some external sources. So I have, because this is under the natural condition, but if you go for the natural conditions, still this contamination exists. So how can I remove this contamination? So we use a technology called simulation optimization model. So the question comes that what is the importance of such models? So the one simple thing is, if you have to decontaminate any groundwater system, the cost of removal of contaminant is very high. So you need to do the planning. So for that planning, you should know where to set up your wells and how you should inject the this water to decontaminate this BTEX compound. So what we do is, this is simulation model, this is optimization model. So this optimization model is calling this simulation model again and again with the two objectives. It means it wanted to optimize the location of the wells and the pumping rates. So this is one of the model which I also developed and got published in one of the journals. So this is the summary of this model. Means what I am trying to do is, I wanted to minimize the cost and I wanted to minimize the violations of water quality, right? So whenever you want to clean the groundwater, you cannot go with the random choices. You need to do a planning. So when we are saying planning, it means you need to have an optimal system. The optimal system means that the cost of remediation is less, right? So how can that cost be less? So we need to do the study. So for that study, we can use models. So the model which I developed, so that I have applied with two main focuses. I wanted to minimize the cost and I also wanted to minimize the violations, right? So when I am saying the violation means if the standard limit is 2 ppm, right? So suppose somehow you are within the 2 ppm, it means the violations are 0. But if your contaminant concentration is exceeding that limit, it means that there is some violations, right? So we cannot always make that violation 0, but at least we can try those violations to be as minimum as possible. So I will show you the application of this model for a very simple problem. So if you look at this diagram, you see that this is a BTEX contamination or any distribution of any petroleum products in a groundwater. So these are some properties which I need to feed into my model, right? So these are the monitoring wells, right? So the contaminant is traveling in this direction because the groundwater is moving in this direction. So I have applied that model into this problem. So if you have studied this groundwater hydrology in your subject, I hope you know the term called hydraulic conductivity. Have you heard of that term?
Yes.
Right? So hydraulic conductivity is a property of a groundwater system. So it means, but we do not know that what is the hydraulic conductivity of this aquifer system. So in real world problem, we go into the field, we collect data, and we know that this is the hydraulic conductivity. But for this simple problem, what I did is, I assumed some random scenarios, that there could be multiple scenarios of hydraulic conductivity. So these are the random scenarios of hydraulic conductivity, that it could be, the distribution could be like this. So you can see the ranges are different for different fields. So this is the distribution of hydraulic conductivity for field 1, field 2, field 3, field 4, field 5, field 6. So you can create n number of distribution. But I have only assumed this 6 number of distribution. So means I will apply my model to all this distribution to check its capability. So as I mentioned that I have developed this new model called BioEFGM. So first I should validate it, means it works or not. So you can see that I have this is the model which I developed, and this is the model which is widely known in the world. So you can see that the results for this model as well as this model are close to each other, right? So it means the results of this model will be validated for the future studies. So here I am showing that this is the concentration distribution along the central line, right? So when I am saying central line, it means if you draw a longitudinal axis like this, and I wanted to see that how this contamination distribution looks like over this line, only over this line. So that I have plotted into this figure. So here idea was to check whether this model performs well or not. So you can see that the results in all the cases are matching, right? So whenever in research you develop any other model, any new model, so you need to validate your model with the existing models, right? That is something, a basic thing. So this is natural biodegradation of BTEX plume. So you can see that in this picture the contaminant was over here, but after 7 years you can see that the contaminant has reached near the monitoring wells. I hope you can see these pictures. So this is for conductivity 1, this is for conductivity 2, this is for conductivity 3, and all the 6 conductivity. So you can see that the contaminant has crossed this monitoring wells. So since I have taken this simple hypothetical problem, so you can also think of a large real world problem where you don't want that your contaminants reach into your these wells, right? Because from the wells we extract water and we drink that. So here what we want to do is, I wanted to minimize this concentration in such a way that they do not reach into these monitoring wells. So I will be applying the in situ bioremediation. So as I mentioned that I have to reduce 2 things. One is cost, another is violations. So if you go for multi-objective optimization problem, this is very well known term called Pareto optimal solutions, right? So you can see here that this is the Pareto optimal solution. So when the violation is less, suppose the violation is 0, the cost is higher or less? When the violation is 0, the cost is higher or less according to you? Higher. It means when you want to clean better, you need to invest more.
Yes, sir.
Right? So you can see that if the violation is increasing, the cost is decreasing. The one thing is clear that the cost is higher when you want to achieve higher standards. Now the next question is, so this is called as the Pareto optimal solution. The people who study this course on optimization, this term is very well known called Pareto optimal solution. So this is the solution which I have obtained through my model called simulation optimization model. So in my PPT you have seen the word called multi-objective. In my first slide you saw multi-objective. Why I am saying multi-objective? Because there are 2 objectives. One is the cost, another is the violation. So these are the results for the another conductivity fields. So here you can see that also that similar sort of trend I can see, right? But the important thing is that here the cost is $1.4 lakh, but here the cost is
1.8.
$2 lakh, right? It means when you have to clean a groundwater system where the conductivity is homogeneous, you need to spend less time, you need to spend less amount of money. But if the system is heterogeneous, then you need to spend more money, right? So we need to do the scientific studies to arrive at this conclusion. So these are the results of the model. So these are the results when my standard is 5 ppm, means I wanted to bring all the contamination below this 5 ppm. Okay. So this is the Pareto optimal solution by this model. In addition to this is the pumping policy, right? So as I mentioned that you cannot randomly decide the location of the wells, you cannot randomly decide the pumping rates of the wells, so you have to apply the model. So when I apply this model, my model is telling you that in case of heterogeneous conductivity field, you need to have 2 injection wells through which you can send water, and that water will contain the oxygen. That oxygen will be delivered to the contaminant. So these are the locations of or the coordinates of those wells, and these are the pumping rates, right? So you need to pump water at these rates in the first. So you can see that this is the injection well, right, through which I am injecting water, and that has oxygen, and that oxygen is being taken up by the contaminant. And this is the extraction well, so we also extract water so that these plume do not go here and there, so just to maintain the hydraulic gradient. So can you tell me what is the maximum concentration of contaminant in figure A? What is the maximum possible concentration of contaminant in figure A? If you can refer to this bar. 35. If you go to the second, means after 2 years, what is the maximum concentration?
25.
it means bioremediation is working or not? Working. In the third year, the maximum concentration is? 12. In the final one?
4.5.
And what was my standard? 5 ppm. It means what I wanted to achieve, I have achieved it. So, it is not something a color plot. This is two wells, injection wells and extraction wells, and there is a policy. Policy means I am pumping with these rates. Right? So when I am applying that policy, you can see that in situ bioremediation is occurring. This is for the homogeneous system. Remember one thing, these two are in the same line. These two wells, injection, extraction. But if you go to the heterogeneous conductivity field, one thing is very much clear that what is the maximum concentration here? 4.5. It means in situ bioremediation is also working here, right? Apart from this, there are few things which you can observe is, you can see here that these two wells are not in the same line. So can you tell me how these two location has come? From where I have got these two locations? Any guesses? Means the well location is here, this well could be here also, but why here? Why here? The answer is these are the optimal well locations. If you go with these positions, your cost will be less and your violation will be less. And I have received these locations through the model which I developed called Bio-EFGM and SGAT. Right? We cannot randomly decide the location. That is something called optimization. Again, these are the breakthrough curves. So I will not talk much on these. These are the variation of concentration with the time. So these are well known to the people.
Once again, I thank the Department of Civil Engineering, IIT Sindri, for giving me the opportunity to present my work with you. So, without much delay, I'll come to the topic. Today I'll be speaking on the role of MICP, which is microbial induced calcite precipitation, in geometrical stabilization as well as for contaminant mitigation. So, this is relatively civil engineering, and almost all the civil engineering applications are actually there with MICP. So I have tried to make the slide as simple as possible. So in case if you have any doubts, you can actually ask me during that time. So these are the contents of my slide. Basically, I will be speaking about some introduction about the bioremediation, and then more detailed about the fundamentals of MICP, and then we will see some work on which we have done in our lab, and then how it is related for contaminant mitigation, that also we are going to see. So before proceeding, I must actually acknowledge my students and also my funding agency, Science and Engineering Research Board, for actually giving me a project on MICP for stabilizing coal ash. So, and my PhD students who are extensively worked and published their work in some reputed journals. So first, what is bioremediation? I think I must also thank Dr. Pathania for actually setting the stage and giving in-depth idea about the bioremediation. So I'll just briefly talk about what is bioremediation. Here we are introducing some kind of biological means to actually remediate the pollution. So either it can, mostly it is microbial based, or some microbes, sometimes fungi, algae, all these kinds, and even some plant based application is also there, where we try to reduce the contaminants. So for this process, we should have, certain factors are actually responsible. It should be there, like microbial activity, which is basically the specific microorganisms. We know that the microorganisms are present everywhere. It is also present in the soil. So when we talk about bioremediation, the presence of indigenous means the microorganisms which is already there in the soil. So So if that is present in the soil, which is actually one of the important requirement for bioremediation to be successful. So that is one thing. And then the availability of contaminants, because certain microorganisms like bacteria, they eat these, or they actually feed these contaminants, and then they actually try to reduce it. They make it into some simpler products. For example, the oil contaminated contamination due to oil, so they actually feed, they are all organic compounds, so they can easily feed on those organic compounds and try to make it into simpler products. You have already seen some examples from the previous session. Then obviously there should be some presence of certain environmental conditions. It should be present, like oxygen, which is the mandatory requirement. Although there are some bacteria which can also work on in the absence of oxygen also, but these are some conditions, like the proper temperature should be there, because if the temperature is very high, if it is very low, the bacterial activity will not work properly. Then the nutrient supply, because without nutrients, this bacteria or this biological system will not work properly. You need to give something to eat, right? Just like we eat and get energy, similarly biological activity happens when we provide certain kind of nutrient to them. And then therefore for aerobic and anaerobic conditions, we should have either oxygen, nitrate, sulfate, all those things are there. And we have lot of applications of MICP, we will see. Now, challenges in environmental remediation using bioremediation is that mostly bioremediation, you will see, it is mostly applicable to those compounds which can easily be biointegrated. For example, the organic contaminants. Organic contaminants, volatile organic compounds, these can easily be degraded using bacteria. But what happens when you have contamination with heavy metals like lead, cadmium, mercury, all those? Bacteria cannot be able to degrade them properly. Although they can try to reduce it by absorbing them, but they cannot reduce it properly. So for that, we can have to think in some other way. So bioremediation strategies actually focus on immobilizing, transforming or extracting the heavy metals into, and so that it reduces the environmental risk. And we need to have some sustainable technologies for applying these techniques. There are various strategies for heavy metal. We can actually see the bioaccumulation, where these different bacteria, they absorb these heavy metals and other contaminants from the contaminated soil. These are some examples. As you can see, we have actually n number of species available to us, which we can actually supply it. But if they are already present in the indigenous conditions, that is having an advantage. Then the microbes can also convert the toxic heavy metals into less mobile form, transfer easily to other places. Then bioleaching, phytoremediation using plants. We grow certain plants, at certain places, so that it absorbs the heavy metal concentration. Phytoremediation has been found to be successful. As you can see, that sunflower is actually a very good, source of phytoremediation for radioactive contamination. In Chernobyl, Russia and all, you might have heard about those disasters. There are many places they have used sunflower to reduce the contamination risk, especially for the radioactive. Then even mustard, our Indian mustard is also a good source of phytoremediation. Then microbial induced calcite precipitation, I will focus more on this MICP. So here, what is this and all, we will discuss in the coming slides. And here, basically, it is a process in which the microorganisms actually generate a typical enzyme called urease enzyme, and that urease enzyme basically break down the urea into different forms.
Now, future endeavors. It was indeed an insightful session.
Gratitude is the fairest blossom of all virtues. To express our sincere appreciation, I now request Professor Prashant Ranjan Malviya Sir, Assistant Professor Civil Engineering Department, IIT Sindri, to present the vote of thanks to Dr. Anil Kumar Sharma Sir for his presence and contribution to this session. Sir, please.
Thank you, Sumit and Soumya. Respected head of the department, senior professors, my colleagues, and my dear students. I am so thankful to one of my guru, Dr. Anil Kumar Sharma sir, from NIT Patna to grace us with the importance and utilization of MICB for soil treatment. Actually, within a very short period of time, we communicated sir, and sir responded very well, and sir is present here today. So I am so much thankful to sir for this within short period of communication he has done this. Sir, your presentation was too easy to understand for the students, and it was very helpful so that they can apply such concepts in their project works of UG, PG and PhD also. Especially from geotechnical background, and they will be benefited with this new era topic and research work. Thank you, sir. I would also like to extend my heartfelt thank to Director Bit Sindri in absentia and head of the department to give this opportunity to coordinate this event. This is very burning topic in the field of civil engineering in this present era.
Invite Dr. Nishikant Kisku sir, as Assistant Professor Civil Engineering Department, IIT Sindri, to felicitate Dr. Anil Kumar Momento.
हेलो गाइस, तो अभी हम लोगों का फाइनली ख़त्म हो गया है सारा प्रोग्राम। और जिन लोगों का बायो रेमेडिएशन पे उस टॉपिक पे मतलब प्रोजेक्ट था, फाइनल प्रोजेक्ट है अभी कॉलेज का, तो वो लोगों के लिए तो बहुत ज़्यादा ही अच्छा मतलब था कि ऐसे प्रोजेक्ट देख लिए, जैसे खुद को एक्सप्रेस कर पाएंगे या फिर उस टॉपिक पे अच्छे से बोल पाएंगे और उस टॉपिक के बारे में जान पाए आज का जो प्रोग्राम था उसके थ्रू। तो मेरा तो वो टॉपिक नहीं था, बट मैं भी काफ़ी इन्जॉय की, थोड़ा नॉलेजफुल था, तो अच्छा ही रहता है सारा प्रोजेक्ट। तो फ़िलहाल अब ख़त्म हो गया है, अब हम लोग जा रहे हैं रूम ना, फिर लंच करेंगे, फिर आज का दिन इस तरीके से कॉलेज का ख़त्म होगा। तो काफ़ी अच्छा लगा, और मेरे जो गाइड थे वो सर से भी मैं मिल कर के आ रही हूँ। तो पर्सनली कॉलेज का दिन ऐसे रेगुलर नहीं होता है, बट जितना भी होता है कोशिश करना चाहिए कि अटेंड करें। तो बाय बाय आप लोगों को। स्तुलिका बाय बाय बोलो, बाय, मिलते हैं नेक्स्ट व्लॉग में।